Good morning, students. Welcome to online chemistry class of class 11. Today we will discuss some of the periodic properties and their variations. The first periodic property is ionization potential or ionization enthalpy. It is the minimum amount of energy required to remove an electron from an isolated gaseous atom in its ground state. That is, in isolated gaseous system, this atom is not under the influence of any other force. So whatever minimum energy is needed to overcome the nuclear pull from the loosely bound or the valence electron, that is called the ionization energy. So when the species X in gaseous state is losing one electron, in doing so whatever energy is being supplied to make it a cation, univalent cation, this is called the first ionization enthalpy. Similarly, when we take out the second ionization enthalpy, second electron from a unipositive cation, this is called the second ionization enthalpy. When we take out the next one, this is called the third ionization enthalpy, and so on. So accordingly, these are called the successive ionization enthalpies. Actually, this measure of successive ionization enthalpies are in the order of higher ionization enthalpies are always greater than the next lower ionization enthalpy, because the positive ion has more effective nuclear charge which holds the remaining electrons more firmly, so a large amount of energy is needed to remove the electron from it as compared to the neutral atom. Some important features are: this ionization enthalpy is a measure of the tendency of an atom to lose the electron. That is, the atom which has a tendency to lose the electron will have a low ionization enthalpy. We measure this ionization enthalpy usually in kilojoule per mole or at times in electron volt per atom. 1 electron volt per atom is equal to 96.49 kilojoule per mole. Let's see the factors that determine the ionization energy. One is the screening effect or shielding effect. So greater is the screening effect, easier is the removal of loosely held electron, and lesser will be the ionization enthalpy. The next one is nuclear charge. The ionization enthalpy increases as the nuclear charge increases, because the nucleus with greater nuclear charge bound the electron more firmly, and hence large amount of energy is needed to remove the electron from the atom. The next one is electronic configuration. As I said, that exactly half filled or completely filled configurations are very stable, thereby, for example, D5, D10 or F7, F14 are exactly more stable. So this configuration with half filled or fully filled or vital is more stable, and therefore the atoms with such configuration is expected to have a very high ionization enthalpy. The penetration effect, it is specially for a multi-electron atom. In order of penetrating power of different electrons of the same valence shell, means with same principal quantum number n, it follows that s orbital followed by p, then d, then f. If penetration power is more, the electron will be more close to nucleus, and thereby the ionization energy will be higher. Let's see its variation in periodic table. In a period As we move from left to right, the successive addition of one electron results in increased nuclear charge. But since the electrons are added to the orbitals of same energy level, that is same n value or principal quantum number level, the shielding effect remains same. And the shielding effect is not enough to compensate for the increased nuclear charge. So the increased nuclear charge finally predominates the shielding effect across a period, and as a result the outermost electrons are more and more firmly held. Therefore the ionization enthalpy increases across a period. Though we have certain exceptions like transition elements show a small variation in ionization enthalpy. Ionization enthalpy of group 15 element is quite higher because of the half-filled orbital configuration, or ionization enthalpy of elements of second group is higher than that of group 13. So all these are due to some other electronic configuration effects. In a group, on moving down, the ionization enthalpy decreases, as because the nuclear charge increases due to addition of electrons. But since the electrons are added to new energy level, that is finally the distance between the valence electron and the nucleus increases, the atomic size increases, the shielding effect on outermost electron increases due to increase in the number of inner electrons. And the increased shielding effect predominates the increasing nuclear charge, and therefore the ionization energy is decreased because less amount of energy is needed to remove the electron from valence shell. The next periodic property is electron gain enthalpy. When an electron is added to a gaseous atom in its ground state to convert it into a negative species or negative ion, the enthalpy change accompanying the process is called electron gain enthalpy. It also measures the ease with which an atom attracts an electron to form an ion. It could be positive, that is endothermic. It could be negative also, that is for exothermic. That is, the electron gain enthalpy is usually measured again either in electron volt per atom or it is in kilojoule per mole. And the conversion of electron volt per atom and kilojoule per mole is already being discussed. We have again the successive electron gain enthalpy. That is, when a single electron is added to the isolated gaseous state, the valence shell of the atom, it forms a univalent anion, and whatever amount of energy is released in doing so, it is the first electron gain enthalpy. Now it's obvious that once the anion is formed, to add one more electron to this anion is quite difficult because there will be a repulsion between two negative species. Hence, some amount of energy has to be provided outside to make the electron added in the negatively charged species. Therefore, the higher electron gain enthalpies are usually positive, or these are the energy absorbed. Here I had given the example of oxygen, the first electron gain enthalpy and the second electron gain enthalpy. The first one is energy released while the second one is energy absorbed. The factors that affect the electron gain enthalpy are: number one, atomic size. As the atomic size increases, the distance between the nucleus and the outermost shell increases. The force of attraction between the two decreases, hence the electron gain enthalpy becomes less negative. Next one is nuclear charge. As the nuclear charge increases, the force of attraction between the nucleus and incoming electron increases. So the electron gain enthalpy becomes more negative. The electronic configuration. In case of elements are having exactly half-filled or completely filled outer shell, because of their higher stability, energy has to be supplied to add an electron. Hence, the value of electron gain enthalpy will be positive, as in the case of noble gases always. Its variation in periodic table. Along a period, from left to right, the effective nuclear charge increases and hence the size decreases. Thus, the added electron on an average would be closer to the nucleus. That means it will be strongly attracted by the nucleus. So, the value of electron gain enthalpy becomes more negative as we move from left to right. Along a group, that is from top to bottom, the size of atom increases. So the distance between the nucleus and incoming electron also increases, or force of attraction between the nucleus and incoming electron decreases. Thus the value of electron gain enthalpy becomes less negative. Though we have certain exceptions, so that all exceptions we will do when we will be studying all the specific elements in the S block, P block or D block elements. Next property is electronegativity. It is the ability of an atom of a chemical compound to attract the shared pair or bonded pair of electrons towards itself. That means there is a point of difference between the other properties like electron gain enthalpy and ionization potential, which are only in the isolated state, but it is in the combined or bonded state. So the greater is the electronegativity, higher is its tendency to attract the shared pair of electron. So we can say that fluorine is the most electronegative species because it can attract the shared pair with maximum extent. The factors that affect the electronegativity are atomic radius. As the atomic radius of an element increases, the electronegativity value decreases. So it is inversely proportional to atomic radius. The electronegativity is directly proportional to effective nuclear charge, because if the effective nuclear charge will increase, the electronegativity will also increase. The electronegativity increases as the oxidation state of the atom also increases. That is, the number of positive charge increases, electronegativity will also increase. The other two factors are marked only: hybridization and nature of the substituted groups attached. This part will be discussed in chemical bonding. Let me tell first the hybridization, then the variation of electronegativity with S character. So this part we will do in chemical bonding, and the nature of substitution is a part of electron displacement effect. In fact, it is a combination of inductive effect only. So this too we will see afterwards. Only this five factors I have enlisted, but this too I'll explain later. Variation in periodic table. Across the period, on moving from left to right, the effective nuclear charge increases and the size also decreases. So the value of electronegativity increases due to increase in attraction between the outer or the valence electron and the nucleus. On moving down in a group, as the atomic size increases, the force of attraction between the valence electron and the nucleus decreases. So the electronegativity also decreases. Application of electronegativity. The major two applications are in assessing the nature of bond, whether it will be ionic or it will be covalent, or it will have 50% ionic or 50% covalent character. And one is metallic and non-metallic character. So now the thing is, if the participating atoms are A and B, and we will find the electronegativity difference between A and B is less than 1.9, the bond is a covalent bond. And if the difference is greater than 1.9, it is predominantly an ionic bond. But if the difference is equal to 1.9, it has 50% ionic character and 50% covalent character. The next one is metallic or non-metallic character. So a species or an element with low electronegativity is usually a metal, and a species with high electronegativity is usually a non-metal. Next class, we will conclude the entire chapter along with the question answer discussions also. So, by this time, please do prepare and feel free if you have any doubt in the official WhatsApp group. Thank you.